Howdy y'all, Mr. Causey coming to you from beautiful Atascocita, Texas with another homework helper. And today we're going to talk about oxidation states of sulfur. So you'll need a periodic table and you're going to need a polyatomic ion chart. And I'm going to make a few assumptions. I'm going to assume that you understand oxidation numbers, that you know how to determine charges, that you are familiar with periodic table, and you know the oxidation rules. And if you have any trouble with any of these, be sure to go to my channel and find a YouTube video for that situation. Now, sulfur has 4 common oxidation states: 2 negative, 2 positive, 4 positive, and 6 positive. But 2 negative is the most common. But finding the right one takes a little bit of work. Oxidation states depend on the type of bond, such as ionic or covalent, and it depends on the shape of the molecule, like linear, angular, and tetrahedral. It also depends on the other elements involved. So you'll have to think about each compound. Calcium sulfide and hydrogen sulfide might be different than persulfuric acid. Sulfuric acid, or persulfuric acid here, has a little bit different charge. So what we're going to have to do is think about this one and determine what it is. So the problem here is, what is the possible oxidation of sulfur in H2SO5, which happens to be, because of its extra oxygen, not sulfuric acid, but persulfuric acid. And when I think of oxidation, I think of charge. So in order to find the charge, I'm going to have to probably find the shape of this molecule. So let's go to the magic blackboard. H2SO5, I'm going to need to find the central atom, and hydrogen can't be the central atom because it only has one bond. So that leaves me either sulfur or oxygen, and it's probably going to be the sulfur because oxygen just has too many atoms. So let's write sulfur down. Distribute the oxygens around the sulfur and put that extra oxygen out on the end there. It doesn't matter which oxygen you put it off of. I just did that because, well, that's where I have the most blackboard. Now, let's go ahead and put the hydrogens in. And we want to keep it symmetrical. Put the bonds in. We know there has to be at least one bond on each of these, but 2 of these oxygens are missing a double bond, so let's put that double bond in. And we have our molecule. But we also note that there are going to be 6 bonds on the sulfur. And since oxygen has a greater electronegativity, sulfur loses 6 electrons. That gives us a 6+ charge. Now that wasn't so hard, was it? So the answer to this problem is 6 positive. Let's recap. You determined the molecular shape. You drew Lewis structure. You determined the bonds on sulfur. And you found the oxidation of sulfur. Awesome! Thanks for watching. Give us a thumbs up, please, and check out some of my other videos. And most of all, don't forget to subscribe. And happy ions.